Hi, this is Neal Neslusan, Vice President of Sales and Marketing at Multify, and today I'd like to talk to you about the path to 400 gig and how a proper plan for 400 gig includes immediate work. First, let's address the status of 400 gig. There are many standards bodies, most notably the IEEE, the ITU, and the OIF, that are working on all the various standards that govern the technology. The IEEE is now finalizing the PMD layer for 400 gig. Additionally, COWI4, an interface that runs between Macs and modules, among other connections, has been defined for some time for 100 gig connections and will be used for initial 400 gig deployments. The IEEE is also defining the follow-on connection to COWI4 called CADAWI. At the ITU, the OTU5 definition is being worked, and at the OIF, the 25 gig and 50 gig electrical interfaces, called CEI28 and CEI56, are defined or in the process of being finalized. The 50 gig electrical interface for chip-to-chip and chip-to-module connections will most likely be PAM4 based. On the components and capabilities side, it is generally accepted that the FPGA and IP vendors will lead the market with IP blocks performing various 400 gig functions, such as a MAC function or an OTN framer. The aforementioned PAM4 is really an enabling technology for 400 gig, allowing twice as much information per symbol to be transmitted as compared to normal NRZ. On the Ethernet side, switches and MACs should come to market very soon supporting 400 gig. Finally, for optical modules, the CDFP MSA has been formed and initial definitions of modules supporting 400 gig transmission are being finalized. For the optics that plug into those modules, initial solutions will make use of 25 gig optics for a 16 by 25 gig solution. But more spectrally dense solutions are desired, and one would think this means faster lasers. With the right silicon technology, this is not the case. The industry does not have to wait for 50 gig lasers, and we'll show you why. This is a great illustration from the CDFP MSA webpage. The immediate market for 400 gig is large data centers and the connections into them. This page graphically illustrates the need for 400 gig. It all comes down to faceplate density and how much bandwidth the switch can realize at that faceplate. The key is the number in the bottom right that is circled in red. For a single row of optics on a standard 365mm faceplate, the CDFP module has nearly 2.5 times the faceplate density of the QSFP28 and over 2.5 times the density of the CFP4. The ability to present as much bandwidth as possible at the faceplate is a key measure in the profitability of operation of a mega data center. Here we see an illustration of the CDFP module, and the obvious question is, what is on that fiber connected to those modules? The initial definition of the module supports a 16 by 25 gig solution targeted at multimode fiber VCSEL installations, which means there are 16 signals on 16 fibers, each carrying 25 gig per second of data. Perfectly acceptable for the short-reach VCSEL multimode fiber world. But what happens for the next step into the single-mode fiber world? The standards bodies are discussing if the next standard should be 8 by 50 gig or 4 by 100 gig. Multify asserts that the right choice is to go with as few lambdas as possible, as it is always cheaper and lower power. There are two single-mode fiber standards to consider, 1550 nanometer and 1310 nanometer. For 1550 nanometer, the fiber usually used in metro connections outside a data center, the choice is obvious. A 4 by 100 gig solution should be implemented for no other reason than superior spectral density on the C-band, which is valued outside the data center. For the 1310 nanometer case, even though spectral density in the fiber is usually not a concern, we believe the right choice is also 4 by 100 gig, for the simple reason that the power and cost will be lower as compared to an 8 by 50 gig solution, due to less silicon and fewer optics. Given that, what should an aspiring module company or systems company build, and what should a network operator demand from them? We would propose a base CDFP module with a variety of optics solutions that would allow for 3 distinct products. A client-side 1310 nanometer module with a reach of 2 kilometers, a client-side or short-haul 1310 nanometer module with a reach of 10 kilometers, and a line-side short-haul 1550 nanometer module with a DCM-enabled reach of many tens of kilometers. And all these solutions can use today's 25 gig optics and do not need to wait for 50 gigahertz optics. The modules would support standard 4 by COWI4 in the client and would present either a single fiber to the network, if an optional optical MUX-DMUX is included in the design, or 4 fibers to the network, each fiber and lambda carrying 100 gigabits per second of data. This is the module that should be developed now, and we look forward to working with you on it. So in summary, why do 400 gig now? Well, the reason is to take a leadership position and enjoy the benefits of being first to market. I look forward to talking to you soon.